Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Maisara binti Zafwan. My matric number is MA20466. So today I would like to present our report project is car engine. So this is my group members. So the first one is Ameh and Asma, Tasha, and also me, Sarah. The main point of the project. So the first one is develop a virtual instrumentation system. Number 2 is collect data from sensors. Number 3, analyze the data with DesiLab software. Number 4, measure the acoustic output of a car engine. Number 5, use a microphone to capture the sound. Number 6, input the sound data into DesiLab. And the last one is apply what we've learned in class to the project. The principle of application microphone. A microphone turns sound into electrical signal using a vibrating diagram. Industrial application. Microphones check vibration in machines, find cracks in materials, measure noise for safety, and test audio products for quality. Complete sensor system. The microphone converts sound into digital data, which is processed and displayed by software like DesiLab. Theoretical background. The vibration and acoustic measurement for the car engine. Vibration and sound analysis improve engine performance and comfort. Vibration sensors measure movement, while acoustic sensors measure sound in decibels. Data is collected using a data acquisition system and analyzed by time or frequency. So the application of car engine. This technique help improve engine design, reduce noise, enhance comfort, detect problems early, and optimize manufacturing processes. The next is methodology. So we have 3 methodology, which is material and equipment, DesiLab setup, and also measuring sound pressure level. So the first method is material and equipment. The first one is car engine, the test subject for the experiment. Number 2, DesiLab software, used to measure the time and frequency domains of the engine. Number 3, Decibel X mobile app, used to measure the engine's decibel level. Number 4, portable microphone, acts as the sound sensor linked to the software. The second method is DesiLab setup. The first step is open a new worksheet in DesiLab and select the analog input module. And next, measure VRMS using the digital meter, which is needed for calculating decibels. Number 3 is link the formula interpreter from the mathematics tree to the digital meter. Number 4 is connect the circuit to another device to record the engine's decibel level. Number 5 is add a write module to store the collected data. Number 6, insert a YT chart module between the analog input and digital meter for time frequency measurement. Number 7, add a data window to avoid data leakage. Number 8, include a FFT window to break down signals into frequencies. Number 9, the last step is add a YT chart after 4 samples to display the frequency domain. The third method is measuring sound pressure level. The first step is start the engines, open the DesiLab, and place the smartphone microphone near the engine. Number 2, press start on Decibel X and decilab at the same time. Then press the gas pedal. After 30 seconds, stop both programs and check the decibel reading. Number 3, use the formula SPL 30 log in 0 divide Vref to calculate Vref using SPL from decibel X and VRMS from decilabs analysis. The calculated Vref help relate the sound signal to the SPL. So the last step is number 4. Enter Vref into decilab. Input the calculated Vref into decilab formula interpreter. Decilab will then detect the input signal in 0 and display the time domain data on the YT chart. So this is our result. The value of RMS is 0.84 volt. The peak of decibel value reached 91.07 decibels. Number 3, the peak voltage is 5 volt, fluctuating between 5 volt and negative 5 volt. The frequency domain graph, the peak frequency value is 0.04 volt, and the last one, the average decibel is shown in the sound meter app. This is our discussion. The first one is voltage variation between negative 5 volt and 5 volt is unaffected by audio frequency as shown in figure 3. Number 2, the FFT analysis in decilab, figure 4, shows a peak of 0.04 volt, but noise may have impacted the results. Number 3, both the sound meter app and decilab measured an average of 97.7 decibels with 0% error. The last one, number 4, voltage variation is unrelated to audio frequency, and both tools provide accurate decibel measurements with minimal error. For the conclusion of our project, the first one is the project was moderately successful and using decilab provided valuable learning experiences. Number 2, key factors for effective measurement include instrument sensitivity, data analysis, signal conditioning, and identifying important parameters. Number 3, conducting measurement in a low noise environment is essential as surrounding noise can distort result. Number 4, collecting data multiple times helps avoid variation that could affect the result. So the last one is number 5. The project enhanced understanding of measurement and instrumentation and its real-life application. That's all from our group. Thank you.